All right, welcome everybody to the Biosolids webinar. We are lucky to have Mike Podash here from Synagro to talk about biosolids. And so Mike moved to Detroit in 2021 to manage biosolid sales out of NEFCO's Detroit facility. And he currently handles sales for the Detroit plant and 2 plants in Maryland for Synagro. And prior to working for NEFCO, he worked for Resource Management Incorporated in New England for 10 years, handling various residual products for agriculture, including biosolids and wood ash. He's a certified crop advisor in the Northeast, Michigan, and Pennsylvania, and has been gracious to give us his time today to talk about biosolids and specifically things in Michigan that affect us as the Western Lake Erie Basin Advisory Group and staff at MDARD and Eagle. So while Mike is speaking, we can all stay on mute. And then if you have questions as the presentation goes on, you're welcome to paste them into the chat at any time. And then during the Q&A, I will read the questions out loud and we can have Mike answer them. Also, I'll note that there are lots of other folks on this call who might know things about biosolids and can answer some of these questions. If that's the case, you're welcome to add answers into the chat or to raise your hand and share that out loud during the Q&A. So we'll do a presentation, Q&A, and then we'll open it up for more of a discussion type conversation at the end. I think this is a good sized group for a discussion, and we can get your questions answered. All right, so I'm going to pass this over to Mike now. And thank you all for attending.
Hello, everyone, and thank you all for coming. I've been very excited for this presentation. I'm glad you took some time out of your day to learn about biosolids and what we're doing. My hope is that you will learn that when it comes to handling biosolids, NEFCO's interests are aligned with the needs of the farmers we serve and some basic principles of environmental stewardship. So today we will start from the beginning. We'll talk about what biosolids are, what we're doing in Detroit. We'll go through our application rate decisions, nitrogen and phosphorus considerations, the rules, regulations, and then we will discuss PFAS and biosolids. I got about 35 slides. I want to leave time for questions. I do think we're going to have some pretty good questions today. And hopefully everyone just gets a nice clear picture of what we're doing. So let's get into it. A little bit about Synagro. We are the largest residuals management business in the country. Synagro recently acquired NEFCO back in September of last year. Our day-to-day operations in Detroit, our personnel and facility are essentially unchanged. Interesting fact about Synagro is in 2023, we distributed 340,000 tons of dried biosolids across the US and Canada. So Synagro has a wealth of experience managing residual materials like biosolids. So how are biosolids classified? Biosolids are the treated solids that have been removed from wastewater at a water resource recovery facility. That's a relatively new term for a wastewater treatment plant. The solids are treated to meet specific federal and state standards, and we test for those parameters continuously in order to maintain our permits. And there are a couple ways you can treat biosolids to meet regulations. Biosolids are primarily they're classified as 2 main types. You have Class B biosolids and Class A biosolids. Class B is often distributed as a cake or a manure-like consistency, or it can be a liquid. The bacteria and pathogen content in Class B is similar to untreated animal manures. The biosolids often require a site-specific permit for their use. If you ever see a sign at a field asking you to stay off of it because of a biosolids application, it is the bacteria that they are concerned about. You would not want to walk over a field that was freshly spread with poultry or dairy manure. And it's no different with Class B biosolids. We just have a specific rule asking to restrict public access to avoid contact with that bacteria. Class A biosolids are often distributed as a cake or liquid or pellets or compost. There is an additional treatment that they have undergone to further reduce the pathogen content. In a Class A biosolid, it is virtually pathogen and bacteria free. In Michigan, it still requires a field-specific permit for its use on a farm, but I don't think that's required anywhere else in any other states. Generally, Class A biosolid can be distributed freely to the public. In Michigan and pretty much anywhere else, you can go into your local garden store and buy a bag of Class A biosolids for use at your home. So the Great Lakes Water Authority they operate the Water Resource Recovery Facility that is across the street from NEFCO's Biosolids drying facility. So they are the wastewater plant. They are the largest wastewater treatment plant in North America and the fourth largest in the world. It's a pretty incredible system. There's a map of the service area on the screen there. They serve 3 million people. At the plant, they do primary and secondary wastewater treatment, and then a large portion of their effluent flow, so what leaves their plant, then goes to us, NEFCO, for treatment into a Class A biosolid. The wastewater received at NEFCO's facility is about 2 to 6% solids, and then we dry it all the way down into a Class A pellet, so that's greater than 90% solids. So again, this heat drying process virtually eliminates the pathogens. We will create about 75,000 tons of these pellets annually through this facility. Just a little bit more about heat drying. As I said, that process is sufficient to eliminate most bacteria and pathogens. The reason we do it is it significantly reduces the volume of the final product, which means reduced transportation. And for our farms, that means reduced number of trips over their fields. It's less tractor time. Everybody's looking for that. There are many benefits to using biosolids to grow crops. So our biosolids provide 2 of the 3 major crop nutrients, nitrogen and phosphorus. That's going to be true of pretty much any biosolid you encounter. And they also provide a significant amount of sulfate. There are also micronutrients in there that are available to crops. The nutrients are almost entirely bound in organic forms, so they are slow release. It takes time, temperature, and moisture to release them. So if you remember your 4 R's, it's a lot easier to hit the right timing for a biosolids application because the risk of leaching and volatilization of nutrients is much lower. The organic matter also has additional benefits in there as well, and we can really take advantage of that in the right cropping system. Using biosolids to grow crops is the pathway for recycling nutrients that would otherwise enter the environment directly. Like it is important to say that the whole reason that wastewater treatment plants are there and the whole reason biosolids exist is because we are taking nutrients out of our wastewater streams that would otherwise negatively impact our environment. And the best thing to do with those nutrients is recycle them back to a farm field to grow more crops and replace other fertilizers that would otherwise be created to do the same thing. Here is the fertilizer equivalent of our Michigan Class A biosolids pellets. High nitrogen, high phosphorus, and a lot of sulfur in there. The values on your screen are averages of 2 years of monthly test data. Each test can fluctuate a little bit month to month, but the averages stay remarkably consistent. Please note the ammonia nitrogen value. it is very low. So when biosolids are surface applied or otherwise applied off season, there's a very low risk of N volatilization or leaching. Again, it takes time, temperature, and moisture for these nutrients to enter the environment, which is what we're after. This is just it's a conservative estimate on the dollar value of the fertilizer we produce. It's just another way to measure the value of biosolids. This is nitrogen and phosphorus. If you were to buy it all as conventional fertilizer for everything our plant produces, it would be about $6.2 million a year to replace this. So here's when we start really getting into it. How do we determine our application rates? First, we are limited by the amount of nitrogen that the crop will use. I use 26 pounds of nitrogen in 1 ton of biosolids to make these determinations. That's the amount of nitrogen available in the first year that you apply. I have to consider all of the nitrogen inputs in the current year. So that might be other fertilizers or other manures going down. I also have to consider residual nitrogen from previous applications of manures or biosolids, as well as any credits from previous crops or cover crops. I am also limited by my soil test phosphorus, which is 150 ppm Bray. That is a fairly high limit, and we'll get into some more P considerations soon. Our typical application rates are 1 to 3 tons an acre, but I have gone as high as 5 tons an acre for high yield corn crops at the right location. Simply put, from doing something like that, I need to work with a farmer who trusts the biosolids. We work out how much nitrogen they want to put through their planter, and then we'd apply the biosolids, and then taking a pre-side dress nitrogen test to determine if the corn needs any more in season. If there is considerable residual N in the soil from various other inputs or previous crops, some farms may take nitrogen out of their planter entirely, or they will just not plan on side dressing at all in season. And over time, with consecutive applications of biosolids, your rates will decrease due to the buildup of residual nitrogen. So a little deeper in the nitrogen considerations, these are my mineralization rates. 1 application of biosolids is good for 4 years of nitrogen credit, according to the table on your screen. Slightly rounded numbers for easy use there. I am strongly incentivized to factor these residual values into our application rates every year. Okay, first of all, it is in the rules. Over applying nitrogen is not a sustainable practice for our business. We can lose our distribution permits, and that would not be good. The second reason is that the biggest challenge I encounter, or I should say the biggest handling issue with the biosolids, is that they are still much more volume of fertilizer than a conventional chemical fertilizer like urea or something like that. It is still a lot more tractor trips and more time. So I like to remind the farms using it that when they're out there on their field spreading, they're spreading for 4 years, and they need to factor that into their pocketbooks so they're not working harder and spending money they don't have to. And they will not necessarily have to work as hard in the future because their rates may drop a little, and that they can rely on that residual nitrogen to come available for future crops. So here's what it looks like with a simplified scenario. If we had a high yield corn crop and a continuous cropping situation, this will demonstrate how that residual nitrogen builds up in the soil pretty clearly. So if we look at this table, starting 4 crop years ago in 2021, if we apply 5 tons of biosolids an acre, that gets you 125 pounds of nitrogen in the red box here. Not considering any residual nitrogen at this point. Again, a simplified example. In the second year, that rate will drop to 4 tons an acre. So now they are getting 100 pounds of nitrogen for the year of 2022 from that application and 63 pounds of nitrogen from last year's. So the total nitrogen available to the crop in 2022 is 163 pounds of nitrogen. In 2023, repeat 4 tons an acre, but now you have 92 pounds of residual N from previous applications. So by the third year, you're getting your full complement of nitrogen from just biosolids. In the fourth year, the rate's got to go down a little bit more. 3 tons an acre gives you 75 pounds of nitrogen for that current year, but your residual is over 100 pounds an acre. So more typical scenarios do include rotations with wheat or soybeans. This was just to emphasize how much of that residual nitrogen can really build up. Applications may skip a year for a farm or be significantly reduced for the next crop, but we still go back and count those N credits. So when we plan for a nitrogen application, we know we're putting down a lot of phosphorus. If you remember from that chart in the beginning, it's about 40 pounds of phosphate in a ton of the biosolids. The majority of this phosphorus is still organically bound or bonded with other metals that would make them more or less unavailable to crops or to the wider environment entirely. So we calculate this phosphorus for a conservative approach. We take the total phosphorus in the biosolids, whether or not it is bonded to a metal or not, and we convert that to total phosphate. So that's where that 40 pounds of phosphate comes from. It is not really all phosphate. These are the concentrations of calcium, iron, and aluminum that are also in the biosolids. We know that a significant portion sometimes of that phosphorus is bonded with those 3 metals. So not all of it is immediately going to be available in the soil solution or available to the general environment. How much of it is actually available? It's a question I deal with a lot. Phosphorus is trickier than nitrogen. I do not have a phosphorus mineralization rate the same way I do for nitrogen. It just doesn't exist. But what I do have is a water extractable phosphorus test, a WEP test. It tells us how much of the phosphorus is soluble and thus immediately available to plants or to cause harm in aquatic systems. So our total average phosphorus in biosolids for Nefco's biosolids is 9,000 milligrams per kilogram, or ppm. The water extractable phosphorus is 600 milligrams per kilogram. So that is 6% of the total phosphorus is water soluble. That's what's going to run off into a stream and immediately be available to use by algae and other organisms. You compare that with a conventional phosphorus fertilizer where 85 to 100% of that total P is immediately available to the environment. So even at a high application rate of Nefco's products at 5 tons an acre, only 12 pounds of that phosphorus is immediately available to cause problems in the environment. The rest of it takes time, temperature, and moisture for soil organisms to work through it and make it available, or it will never be available because it will be bonded with some of these other metals. What does that do to your soil test? So I do not want to oversell this chart. As far as Nefco operations are concerned, we're not that old in the state of Michigan managing this Detroit plant. I do not have a very deep well of test data, but I did want to show some soil test results. So from one of our older customers, this chart shows the field and then the crop year, the soil test result, and then our application rates after those soil tests on the far right column. The individual who farms these fields, they are relatively high, heavy soils. So their soil test phosphorus is going to go up slower than others. And we do see some variation in this chart. I left in this one value, which I, just as a reminder of good soil sampling practices. This field was applied to in November of a year and then sampled in May of the subsequent year. So we see a lot more. Some of the biosolids got right into that soil test. At the end of the day, your soil test phosphorus is going to rise with using biosolids, but we do expect it to rise more slowly than conventional phosphorus applications or from your various animal manures. We emphasize the regulations that protect water quality, and we emphasize good soil management. A healthy soil stays on your field and it can hold more nutrients. I think most of us here probably know what healthy soil means. I myself, I'm a big fan of no-till. I think the science is in on that. I think none of us has ever seen a soil that has not been significantly degraded from conventional farming practices. And when it comes to managing biosolids, the odor is often a strong motivation for tillage. But tillage can be counterproductive for managing the excess phosphorus that we're putting down. All in all, a no-till soil can hold more of that excess phosphorus, and it keeps the soil on the field, which is how phosphorus primarily moves to waterways, as I'm sure you all know. I do deliver biosolids to conventional fields every year, but I do what I can to advocate for healthy soils. So first, customers will often ask me, do they have to till the biosolids in? And the answer is no, absolutely not. It's not required by the regulations. It's not required by NEFCO. The second question that I get often is customers will approach me looking for organic matter for their fields. They will say, I've heard you distribute biosolids and there's organic matter in that, and I want to use that to build my soil. And I like where they're coming from when they start talking to me about that, but I got to ask them, are you using cover crops? Are you reducing your tillage, or have you considered looking at how you can reduce your tillage? Because those two things are going to build the organic matter much faster than just organic matter inputs to your field. Soils, particularly no-till soils, they have increased organic matter, higher cation exchange capacity, increased soil aggregation. They can increase their infiltration rates and water holding capacity. All of that leads to reduced runoff and erosion, which is what we're after. I want to keep my biosolids out of surface waters. Farmers want to keep their soil on their field. And I really like working with customers who are trying to build their soil health as much as they're trying to increase their yields. So getting into the regulations now, NEFCO is regulated in Michigan by EGLE and MDARD. EGLE is our primary regulator. They have all of the biosolids application rules fall under them. MDARD regulates biosolids when they register as a fertilizer. So primarily, the agency we're working with is EGLE. Quality standards. So on my end, when we talk about biosolids quality, we're talking about the heavy metals content. All biosolids applied to land must meet these limits or stricter levels. The limits are for monthly average concentrations. They were initially established by the EPA through a risk-based approach. Some states will further reduce these limits. The table highlights our biosolids averages on the right compared to, EPA, Michigan, and Ohio limits. There are also limits for sealing concentrations of these metals, annual loading rates, and cumulative or lifetime loading rates. For all of the metals on this table, I am never going to hit a cumulative lifetime loading limit. Our numbers are small enough that it takes hundreds or thousands of years for us to reach that for most of these metals. Site permit requirements in Michigan. Every single field I go to requires a site permit. I provide a use label to customers. I collect signatures from landowners and farm managers. We need soil tests taken within the last 2 years, compared to the conventional 3-year soil testing cycle, which is an extra safeguard against building excessive phosphorus in the soil. I develop a field nutrient management plan based on the application considerations we went over previously. I provide every customer with an application map. We review the USDA soil survey, looking at the depth of groundwater. We provide the PFAS notification for landowners and managers. I collect site information forms for simple field details and contact informations. We maintain all delivery records, and I have stockpile time limits, which also helps keep nutrients out of surface waters. These are our application setbacks from surface waters, private and public wells, buildings, homes, and groundwater, all to ensure that nutrients do not enter water. The groundwater one in particular, if the USDA soil survey shows that the water table can be higher than 30 inches, or yes, if it's less than 30 inches from the surface of the soil, we would have to go out and dig a hole prior to application to make sure that it's not right up at the top. I don't really like digging holes, so we just avoid these fields. Here's an example field map that I provide to all customers. This shows a incorporated setback distance from surface water down here, homes, the wells that the homes use, as well as the boundaries of the permit area. I often go out and flag these for new customers when it's their first time on a field, so they get used to the distances from the edges. We also have best management practices that we follow. We developed them in conjunction with the Michigan Water and Environment Association. We further consider site characteristics, like how many houses are around, or are there other businesses or entities where people congregate that might be adversely affected by odor. We consider how the farm is going to manage the biosolids. Are they going to till it or are they not? We consider the application rates they're going for. And when it's time to apply, we also consider soil conditions at the time, as well as the weather forecast. We do not want to deliver biosolids to a field where it can't be spread, where if they sit for a long time. We also don't want dust leaving the field and adversely affecting someone else's property. I like this picture. I just want to point that out. This was from a field in New Hampshire in March a few years ago. I think you can tell where the setback was. And this little strip of green in the tan grass here, that's from when the tractor drove back across the setback, and just a little bit of biosolids get off and the grass loves it. So now we get into the PFAS discussion. I'm sure most of you have likely heard of it by now. PFAS is a family of per and polyfluoroalkyl substances. They are chains of carbon and fluoride bonds. These products have been used since the 1940s in industrial and household products. PFOS and PFOA are historically the most common forms that have largely been phased out of production in the United States. But we are still dealing with their legacy, and we will be for a while. When we talk about PFAS, it's important to understand the units that we're talking in. All of the biosolids test data I've shown you to this point has been in parts per million. That covers the nutrients and the metals contents. But when we talk about PFAS in biosolids, we are talking at the part per billion range, which is getting to be a very small number. And when they talk about PFAS in drinking water, we're talking about parts per trillion, which is an incredibly small number. It's very hard to wrap your head around. One comparison is that it is 1 second of time over 31,700 years. Our detection limits are very low. They're getting better all the time, and I find it pretty impressive overall. So where is the PFAS? Where is it coming from? It is coming from virtually everywhere. On the left of this slide, there's a general list of products that these compounds have been used in our society. A lot of those items represent direct human exposure. Most of them in some way can contribute to PFAS concentrations in the dust in your home, which is a major source of exposure. Just going through some of them, I mean, nonstick pans, cooking utensils, and food packaging. I mean, these are things that touch our food, fabrics that touch our face or our clothes or degrade into dust in our home. Personal care products like makeup can often be very high concentration in these compounds. And I do want to point out that a lot of pesticides incorporate PFAS into their formulas. If you have a herbicide and you want to make it stay on the surface of a leaf, or a fungicide, for instance, you want to increase the surface tension of that and have it cling to a leaf despite a little bit of rain, or if you want to reduce its volatility when it's on the surface of the soil, a PFAS compound is going to be useful for that. The chart on the right here shows the levels of PFOA in precipitation across the globe. The graph is in parts per trillion, and hopefully it's not too hard to read, but on these red bars on the far right, that is the PFOA concentration in precipitation over Antarctica and Tibet, which are two of some of the most remote places on our planet. And in both places, they can detect PFOA in the precipitation at higher concentrations than the US EPA health advisory limit. This is true for rain that was tested over the Great Lakes region as well. We've done a pretty great job spreading these compounds all across the globe. Here's just one more example of that. PFAS in the blood of humans in the US. This chart came from the CDC. Virtually every person on the planet has some level of these compounds in their blood. The good news is that it has been declining, particularly as the production of these compounds has been phased out. So with all that being said, how do we keep PFAS from entering our biosolids? It starts with the water resource recovery facility, the wastewater treatment plant. That's where the process starts. It's very important to note that these treatment plants are not adding PFAS during the process. They don't add any at all. They are receivers of what is used in our wider society. The GLWA has the authority to create ordinance and rules regarding industrial discharges to their plant. They can also engage in voluntary best management practices with various industries that send their wastewater to the plant. They are currently engaged with over 50 companies in this manner, 17 of which have installed or are installing their own treatment filters to prevent the PFAS from entering the wastewater plant in the first place. As a result, they have seen PFAS influent concentrations decreasing at the wastewater plant. They have also recently proposed a local limit for PFOS discharge to the wastewater plant. It is one of the first such rules in the country, and it just shows how Michigan and the GLWA are trying to stay ahead of this as best they can. On the biosolids end of PFAS regulation, Eagle has developed interim rules regarding the concentrations that are acceptable in biosolids that go to farms. We test for 28 total PFAS compounds, That's NEFCO testing our biosolids for 28 total compounds. The rules are based around PFOA and PFOS specifically, but we're monitoring a wider range in case they're having us monitor a wider range in case they want to factor that into the rules in the future. NEFCO is required to notify every landowner and every farm that we work with regarding this PFAS issue. The notification is on your screen here. This is a very well-written letter that explains the issues, what the rules are, and it also shows our PFOA and PFOS test results right on the page. So typically, I will bring up PFAS to the farmer. I will discuss it with them. I will provide them with a notice. If they would like to present it to a landowner on their own, they take a copy with them, or they give them my phone number and I'll talk with the landowner. Either way, before the permit is submitted, we mail out this PFAS notice to the farm and the landowner again to make sure that everybody knows what's going on. These are the actual limits for 2024 that Eagle has set. The limits started in 2021 and they've been lowering them incrementally every single year. To develop them, they tested all the biosolids going to land application in the state of Michigan, and they immediately restricted the biosolids that they deemed were industrially impacted, the ones that had the highest amount of PFOS or PFOA at the time. And then after that, they set these tiered limits that the limits tell us how we can handle biosolids with various concentrations. If we're over 100 parts per billion of PFOS or PFOA, we can no longer go to a farm field. If your PFOS or PFOA concentrations are above 20, your application rate is restricted, and they want you to start looking upstream, if you haven't already, at the wastewater plant to start reducing what's coming in. If your combined PFOS and PFOA values exceed 20, you lose your exceptional quality biosolid status. That's something NEFCO has that we want to maintain, and when we're well under this limit. For Detroit, these are our biosolids PFAS test levels. This table on the right, this is our most recent test. These are all 28 compounds. For PFOA and PFOS, our combined total is 3.3 parts per billion. All of the PFAS compounds tested, their total is 8.05 part per billion. That's a lot of that is thanks to GLWA going back upstream and being aggressive at trying to reduce these compounds from entering our biosolids. So finally, we can talk about some of the impacted farms. These are some high-profile cases that you may have heard of, where PFAS has disrupted or ended, farm operations. The most relevant one to us in Michigan is the Grostic Farm. That farm utilized biosolids from Wixom wastewater plant for several years. They found PFOS in their surface water, in crops, and in beef. The Wixom biosolids tested between 2,000 and 8,000 parts per billion of PFOS. So again, NEFCO, Detroit's operation, we are 3.3 right now. Well, 3 for the PFOS specifically. So one application of the Wixom biosolids is like using NEFCO's for 700 to 2,000 plus years. It's very different. The Stone Ridge Farm in Arundel, Maine is another one that you may have heard of. This farm utilized paper fiber and biosolids from the late 70s onwards, and they ended up finding PFAS compounds in their milk. However, after further investigation, other farms who used the biosolids did not have similar elevated levels. The Maine Department of Environmental Protection investigated this further, and they figured that the paper fiber that was used in the past at this farm was the more likely source of the contamination. Paper was historically coated with PFOS. And when they make new paper at a plant that makes paper out of recycled paper, there is a waste product that is produced. It does often go to farms for lime and organic matter content. And in the case of this farm, that was just very heavily PFAS laden. The Highland Dairy in New Mexico was another high profile case. It didn't have anything to do with biosolids, but I wanted to put it here because their cows were drinking groundwater contaminated with PFOS from the nearby Air Force Base. PFOS is a major component in firefighting foams. And so military bases and your local fire department are often training to stop fires, and they can contaminate the groundwater. And when the cows were drinking this directly, it impacted their milk, which is, again, very different than applying biosolids with a low test level to a farm field. I believe the water at that dairy tested at 12,000 parts per trillion. It was very high. All in all, I have this quote from Dr. Linda Lee at Purdue University here. The general recycling of biosolids to soils has not been shown to be a significant contributor to the nearly ubiquitous exposure of PFAS in the human population. When you start talking about industrially impacted biosolids with very high test results, problems can arise. The majority of biosolids do not fall into that category. Some additional information here. I mentioned the Michigan Water Environment Association. That's a collaborative effort between Eagle, MDARD, the Farm Bureau, and MSU. We have developed some additional educational resources that I have a link to at the end of this presentation. If you have any more questions about it, they're great fact sheets. I really like distributing them to customers to help provide some more info. In conclusion, land application, it is the most sustainable option for managing biosolids. There are still challenges with it, but for the greater environment, it is the best thing we can do. The GLWA is progressing towards becoming energy neutral. Biosolids recycling is an essential part of that process. And our plant in Detroit alone can produce enough fertilizer for 25,000 acres of farmland. And we don't want to see that go away. So thank you again for your time. My contact information is on the screen, and I'll be happy to take any questions.
Thanks, Mike. So you're welcome to put your question in the chat and I'll read it for you, or you're welcome to raise your hand and unmute yourself and ask your question. And this would be a good time for folks to turn on their videos if you're able to do that, so that we can all see each other as we discuss this. Hello, everybody. Does anyone want to ask the first question?
There has to be some questions. There's no way I did that well.
Question.
Yeah.
I guess for me, within Michigan, do you see a particular, regionality of like certain regions that seem to be picking up on the increased use or adoption of biosolids into nutrient management plans versus others? Or do you see hot spots for these, or it's starting to pick up versus others are really not seeming to be much of an open market when it comes to biosolid distribution or anything like that so far that you noticed?
Well, it's a good question. I would say we distribute a pretty wide range, and typically interest grows with word of mouth for me. So we get a good customer. We're using a lot of biosolids in the thumb because we've had some of our older customers there, and word gets around. And so I don't know if it's so much, you know, region specific as as it is that you know, we had a farm with a great experience, and he tells his neighbors, and so that kind of helps develop our markets organically in the various regions where we go. So we distribute a lot to the thumb, and I do have more of a straight south line from Detroit to Ohio, more farms picking up in that region. That's the primary region where Detroit biosolids end up, as well as Canada. We have quite a lot in Canada there.
Great. Okay, we have some questions coming into the chat. So Irma would like to hear more about energy neutral efforts, I assume in producing the biosolids.
When we talk about biosolids being good for the environment, often, you know, we're talking about these are nutrients that are recycled that you are then using on a farm field, and it's replacing greenhouse gas emissions that would be generated if you used a conventional fertilizer in its place. So it's not so much a energy reduction in our process as it is just recycling as a whole. I did mention the GLWA looking to become energy neutral in their processing, and I'd have to send you some more information about that as far as what specifics they're doing. And I hope maybe that gives you a good idea, maybe not. If you have any more detail to your question, I might be able to help.
Yeah, just in this slide, it just mentions that GLE was in the process
Yeah.
of becoming energy neutral. So I was just curious, was that, you know, because they were going to begin to use clean energy, renewable energy, and in the process, or geothermal, or?
Oh, yeah. You know, I should send you some better detail on that. I do not actually know their whole plan off the top of my head.
Yeah, this is Felicia with Synagro. I work with Mike. I figure I just add in, I think we can definitely follow up with some better information, but as a whole, I know that GLWA is definitely looking at different technologies that would bring them to that level. So as you understand, we have the drying facility as one piece of the puzzle, which uses natural gas. So I know that they're looking at other options like digestion and things like that to create a gas that they could also send across to the dryers to offset that. So that's a piece of the puzzle. But like Mike said, we could definitely follow up with more information like that.
Thank you.
Okay, the next question is, you know what types of practices industrial customers are using to reduce PFAS?
Yeah, generally they use activated carbon filters, or I want to say a reverse osmosis filter can also take PFAS out of water streams. So really those industries are just installing that at the end of their system before they send wastewater on to the plant. The GLWA rep I spoke with, he said most of it was activated carbon filters.
Great. All right, the next question is, are out-of-state biosolids permitted in Michigan? If so, is it the same process and limits?
Yes. Yes to both. Yes, you can bring biosolids out of state, but they would still need to follow the same permits and rules that I do.
Great. And Sarah Campbell, I don't know if you want to follow up on your comment you just made.
So GWLA has a lot of things like that Felicia mentioned. They want to move to anaerobic digestion to use the bio gas that is generated during anaerobic digestion to help fuel some of their generators, but they also are piloting biocrude, which is the biosol or oils that are created from biosolids. They have a whole department for investigating new methods of like sustainable methods and technologies. So I can, Irma, if you would like, I can get you in contact with John Norton, who's in that section, his whole thing is just looking for technologies that are sustainable for GLEWA.
Thanks. I can send out an email connecting people after this.
Yeah, that'd be great.
Yep. There any other questions?
You know, I'm curious, let's see, what percentage, you mentioned 25,000 acres, I think that Synagro either applies to or has the potential to apply.
Has the potential from that plant, yes.
Okay.
Yeah.
What percentage of all farmland in Michigan is that? I mean, how big
Oh, I don't know the 25,000 specifically, but I want to say 1 to 2% of farmland in Michigan gets biosolids. That is, I have a great resource I can point you towards to that as well, where you can see the distribution of farmland across the entire country, state by state, and can tell you how much the biosolids production in that state relates to the total agriculture they have. Yeah, if you would just, yeah, we'll connect over the email that will go out. It's some pretty interesting information. Overall, they are a relatively low portion of the nutrients going on a farm fields are coming from biosolids.
most are using fertilizer?
Oh yeah, they're using their own manures or they're using conventional fertilizers. Yeah, like I said, most states in the country, it's somewhere from 1 to 3% or even less of acreage receiving biosolids. There's about 60%, give or take, of all the biosolids in this country go back to farm fields. And that ends up, we grow an awful lot of crops. It ends up not being an enormous percentage of total production. Yeah.
Well, let's hope it catches on.
Yeah, thanks. Yeah, that's what we need. We need that 60% to be 100% for starters. Yeah.
So Doug Darling also has a comment in the chat that Michigan has about 7 million acres in food and fiber production. To give it
Yeah.
into scale.
Well, I might as well just type it in my calculator here.
I also
Yeah,
have a question.
That's
I'm
quite
sorry.
low. Go ahead.
Do you think your facility has a better handle on the PFAS problem than facilities in other states, considering Michigan?
Yeah, I think the rules in Michigan are excellent. You know, when I came here in 2021, I knew that the PFAS notification was going to come into effect, and I was honestly nervous about taking this job and knowing that I'd have to explain to every customer and every landowner I meet that these chemicals that we don't like are in the product I'm trying to sell them. And at the end of the day, Eagle developing these rules has made it so that I can, and they continue to progress and they continue to get tighter and tighter, which it benefits biosolids recycling as a whole compared to facilities in most of the country that do not have these rules. You know, I would say we're in a pretty good position.
Right. All right, we have time for maybe one more question. I also want to note Sarah Campbell put a cool pie chart in the chat that you can look at that shows that 10% is fertilizer is from biosolids, 50% is from commercial fertilizer, and 40% is from CAFO manure. And that's from 2019 data. And is that for the state of Michigan, or what scale is that on?
Yeah, that's for the state of Michigan. To caveat that, that's only manure from CAFO. So if it's not large enough to have a concentrated animal permit, then I don't have that data. But this is the data that I had available to me. So because this question has been asked a lot. So I don't have land comparisons yet, but this is the one set of data that I have because CAFO only counted it once in 2019.
Thanks for sharing that.
Yeah, it's interesting.
All right, well, if there are no more questions, we're about at time, and I appreciate everybody who came to this. We recorded it, and we'll be sharing the recording out in the next WLEB newsletter, and also putting it on the website on our events page where we store all of our event recordings. Feel free to share this with anybody who you think might be interested, who wasn't able to attend. And let's thank Mike for sharing his time with us and all this great information. And I'll be able to follow up with an email to Irma, Mike, and Sarah to make sure we get all that information. And if you have any other follow-up questions, Mike's email was in the slideshow, and you can also ask me for it later if you forget.
Yeah, absolutely. Share my email with anyone.
Okay, great. All right. Thank you, everybody. I hope
Thanks,
you have a good rest of
everyone.
your day.
Bye.
Bye.